Okay, we've been given a rhombus here. We're told that the point A is at 511, and we're told that the line DB, so the line running through the point D and the point B, has the equation y equals half x plus 6, and we have to find the equation of the line AC. Okay, so we're told the line DB, which is there, okay, y equals half x plus 6, and we want this one. Now, this is a rhombus, okay, which means that the two diagonals there cross at right angles, okay? You need to know that to solve this problem, okay? A rhombus means that it's diamond shaped, but all four sides are the same length, okay? If it were a parallelogram, something like this, okay, where these two sides are different length to these two, then the diagonals do not cross at right angles, okay? It has to be a rhombus where all four sides are the same for the diagonals to cross at right angles. Okay. And we're going to use that because when two lines cross at right angles, if you know the gradient of one, you immediately know the gradient of the other because it's the negative inverse. Okay, and we do know the gradient of dB because, look at this equation, okay, for dB, y equals half x plus 6, that's in the form y equals mx plus c, the equation of a straight line where m is the gradient and c is the y-intercept. So we can just read off the gradient. M is a half, okay, for line DB. So the gradient is a half. So therefore, like I said, we can immediately work out the gradient of the line AC. So for AC, okay, the gradient is the negative inverse of this gradient. So in other words, minus 1 over a half, okay, which is, well, that's like minus 1 over 2, so that 2, dividing and dividing again by 2, so it's the same as a 2 being on the top, so it's the same as minus 1 over 1 times 2, so it's just minus 2. Good, so we've got the gradient of the line AC. How do we get the equation? Well, that is one form of the equation for a straight line, y equals mx plus c. And that involves the y-intercept c, where the line crosses the y-axis. However, there's a different form of the equation for a straight line, which is more useful in this situation. It's this. And I need you to learn this, learn both forms. So y minus y1 equals m x minus x1, okay? Now that is the same equation, just in a different form. Instead of having a y-intercept, it's still got a gradient m, but instead of a y-intercept, it's got this point x1, y1 is any point on the line, okay? It's any point on the line. And this is more convenient in this case because we've been given a point on the line. So that's why it's more convenient to use this form. We don't need to work out the y-intercept. Okay, we could use that form, but it's much easier to use this because we just use the point 511. Okay, so x1, y1 is the point 511. So we know x1, y1, we know m, it's minus 2 for AC, so we can just stick it in here and get the equation. So we get, for AC, y minus y1 is 11, is the gradient, m minus 2, m times x minus x1 is 5. There we go. We've won. We just need to rearrange it to put it in this form because you wouldn't leave it like that. It's nicest to leave it in this form, okay? So y minus 11 is equal to, multiply this out, minus 2x minus 2 times minus 5 is plus 10, okay? Add 11 to both sides and we get, for AC, y minus y1 is 11, so y minus 11 is equal to m, for AC m is minus 2, times x minus x1, and x1 is 5, so x minus 5. We've won, we've got it. We have the equation for AC. Now we just need to rearrange it and put it in a nice form. For equations of straight line, when you're presenting your answer, put it in this form, y equals mx plus c. Don't leave it like that. Okay, so multiply out the bracket. Y minus 11 is equal to minus 2x plus 10. Add 11 to both sides, and we get y is equal to minus 2x plus 21. And that's it. The equation for AC. Okay, good. Right, things to take from this question. Firstly, a rhombus, all four sides are the same length and the diagonals cross at right angles, okay? That's only true of a rhombus, not of a parallelogram. All four sides have to be the same length for the diagonals to cross at right angles. When two lines cross at right angles, the gradient of one is the negative inverse of the gradient of the other, okay? You need to know that. And you definitely need to know the two different forms for the equation of a straight line. It's the same equation, just in different forms. This one deals with C, which is where the line crosses the y-axis, but this one deals with the point x1, y1, which is any point on the line. There you go. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.